So we now know from previous lecture that the continents are all moving around, and different parts of the Earth's surface are moving differently. It's not just the continents drifting around, it's chunks of the Earth's surface, plates that are moving. And what's happening to trigger this is that we've got the asthenosphere underneath there, and it's convecting. Now, a couple of important points here. If the Earth's crust were thicker than it currently is, then there would not be a way of the asthenosphere dragging it around as effectively. The other thing that has to happen is you've got to have a mixture of this thin ocean crust that's very dense and this thicker continental crust that is lighter, so that when they come together, it allows the lighter stuff to ride up over the heavier stuff, shove the heavier stuff down. So that means we're constantly recirculating this stuff in here. Okay, now, why is that important? If you did not have this sort of topology right here, then what would happen is that you would not be able to get subduction going on. If you do not have the difference in the density of the ocean crust and the continental crust, you don't get subduction. If you don't get subduction, you do not get plate tectonics. That's very important. Plate tectonics is key to how Earth works. It gives you a rich diversity of landscapes and geologies, and therefore climatary sort of things. These mountains affect the flow of the atmosphere. Again, this is a huge impact right here in terms of what's going on with Earth. Okay, so all of this is a very important thing that's happening, and you don't get that if you don't get plate tectonics. You don't get plate tectonics if the crust of the Earth is too thick. Now, this is an interesting thing because it turns out that Earth's crust is much thinner than the crusts of Venus or even Mercury or Mars. So of all the terrestrial planets, you know, we have the thinnest crust. And it's also broken into these two basic types, continental crust and oceanic crust. Again, we don't find this on the other worlds. That means plate tectonics would have a tougher time operating on those worlds. Now, that means that the climatological conditions are different. Okay, so this is very important for Earth. You know, something had to have happened in Earth's early history to make it different from the other worlds in order for us to have plate tectonics. Without plate tectonics, we would have a much different surface characteristic and therefore a different climate than we have. That would seriously affect life as we know it on this planet. We did say that the things are moving around, and so as they move around, they run into each other. So what happens when plates collide? Okay, so where you have continents overriding ocean, you get that subduction that I talked about before. So that's happening here. Okay, your Asian plates are moving this way. That's happening there. Australia going that way. India is heading this way. Now notice a lot of these here are bumping into each other. That's bumping in here. That's why you get a lot of earthquakes right along in there. Okay, and then India is running into Asia. Okay, so where plates are sliding past each other, like in the West Coast, you know, part of this is going this way, part's going that way. They grind past each other. You get these massive earthquakes. But in India, where India is going one way and Asia is going perpendicular to that, you have giant mountains. India heading north. So India is heading north. Indian plate is heading north. And the Eurasian plate's heading this way, so everything's crunching together right there. So, you know, the Eurasian plate's a little bit, you know, riding up a little bit over this, but you're actually pushing up some of this stuff too. So you get the biggest, tallest mountains on Earth right where these two plates come together. And so this is where you get these collisions. You either get subduction if ocean floor runs into continental crust. If ocean floor runs into ocean floor, you also can get subduction because one's going to be a little bit denser than the other. And you will, when two continents run into each other, you build giant mountains and lots of earthquakes. Some of the biggest earthquakes occur on Earth right here, in the Himalayas and also in the Mediterranean, Mediterranean Sea, where Africa and Asia, Eurasian plate, tend to be bumping into each other. In that case, one moves and the other moves and so forth, and so it's kind of a mess right in there. So there's several places here where this happens, where everything bumps together.